Question: for a toy Leyri locomotive of mass 0.8 kilograms is towing a truck of mass 0.4 kilograms on a straight horizontal track at a constant speed of 2 meters per second. There is a constant resistance force of magnitude 0.2 newtons on the locomotive, but no resistance force on the track. There is a light rigid horizontal coupling connecting the locomotive and the track. Part A, state the tension in the coupling. I'm going to first draw a simple sketch, okay? Simple sketch here. And then I put the forces that are acting on these particles. Now, this is the toy car. Then this is the truck. So we have the tension in this string, and also the same tension is the one that pulls the toy behind, but also it is the one that pulls the truck forward. Now, we have that one there. So this one must be having a driving force, okay? Now, they said that 0.2 newtons, a constant resistance force of 0.2 newtons on the locomotive. It's the toy, okay? The locomotive is the toy. So here, there is 0.2 newtons, but there is nothing here. That means I can put 0 newtons, okay? There should be some resistance, but they said it is not there. So let me just put 0 there. Then, after that, we are going to see, there is something they said here that something to do with constant speed. Yes, constant speed. So for constant speed, what do you know about this? Acceleration is equal to 0. So if we use F, which is equal to ma, when you look at the track here, okay, look at the track, you are going to have now the tension that is taking it forward minus the resistance, then is equal to, since this one is 0, we shall just put 0. Since acceleration is 0, the whole thing here is 0. Now, meaning that the tension is actually equal to 0, as simple as that. Part B, find the power produced by the locomotive's engine. Now, when you look at the toy, that is the locomotive, okay? We have the driving force. Remember, we are substituting in F is equal to ma. So the driving force minus the resistance forces here. So we have the tension, which is 0, minus the resistance force, which is 0.2. Then this one is equal to 0, because acceleration is what? 0. So meaning the driving force here is going to be equal to the 0.2 when this one goes there, okay? 0.2. For constant acceleration, you should know that the driving force is equal to the resistance force. And we know that power is equal to the driving force times velocity. Or you can say it is the rate of doing work. So force times distance, that is work, then divide by time. But distance over time is speed. So that's why we say force times the speed. Okay? Now, we are going to get the driving force. We have gotten 0.2, then times the speed, which was given as 2. So when you multiply these ones, your answer is going to be 0.4 watts. The power produced by the locomotive's engine is now changed to 1.2. Remember, power is directly proportional to the speed and the driving force. You see this one here. So that means one of them has to change in order for power to change. But since all of these parts are under this term here, and they said it is constant speed, then that means that there is the change in the driving force. So we have to find the new driving force. New driving force. And by the way, there is a part C, find the magnitude of the tension in the coupling at the instant that the locomotive begins to accelerate. So we have to find the new driving force, which is equal to, of course, right from here, if power is equal to the driving force, then times the velocity. So that means that The driving force will be power divided by the velocity. So this new power, then divided by the velocity, which is 2, and then this one will be 0.6 newtons. Now, using F, which is equal to ma, let us look at the individual forces which are acting on the toy and also on the truck. So on the toy, right from here, is a driving force, then minus these 2, okay? So we shall have the driving force is 0.6 minus, there is tension, there is also 0.2, then is equal to the mass of the toy was given as 0.8. So 0.8 A. And then when we go to the truck, for the truck, the masses that the forces, we are seeing the tension, and then there is no frictional force. So tension minus 0 then is equal to 0.4 A. Okay. Now from here, of course, these are two equations that we can solve simultaneously. This is a minus and this is a plus. So to eliminate t, I will just add. When I add, the t will disappear. Then 0.6 minus 0.2, that will be 0.4. And then 0.8 plus 0.4, that will be 1.2 A. So meaning acceleration is equal to 0.4 over 1.2. Of course, this is a third. So acceleration is going to be equal to a third. That is meters per second squared. What do they want us to find? The magnitude of the tension. Okay. Now, the tension I can substitute here or here, but of course the easiest would be this one here. Not so. So the tension is therefore going to be equal to 0.4, then times a third. Okay. I can write it as a decimal or a fraction. 0.4 is the same as 2 over 5, then times a third. So 3 times 5, that is 15. So meaning our tension is going to be equal to 2 over 15 newtons. That is that.